Meet Claire Devane. She's your typical 3-year-old. Except Claire was born without a right ear. And she could be among the first recipients of one of medicine's most cutting-edge technologies, bioprinting. Bioprinting is the latest form of 3D printing. Imagine using a home printer, but instead of working in just 2 dimensions, this printer creates in 3 dimensions. A nozzle lays down a stream of plastic, metal, or ceramic. Layer after layer, it slowly forms an object. Everything from toys to cars. Even human tissue.
If you think of any tissue in the body, it's this intricate combination of cells and matrix in just the right particular order. And so the idea with bioprinting is that we can impart that organization right from the start. Think of this like Jell-O that you might make in your kitchen.
About a month ago, Larry Bonassar, an associate professor of biomedical engineering at Cornell University, astonished the world when he printed an actual living human ear.
The whole process of printing is completed within about 15 minutes or so.
15 minutes for an ear?
15 minutes for an ear.
Wow, just order one up.
The printer deposits layers of living cells, forming the shape of a small ear. Within minutes, the cells begin to grow and bind to one another.
This is one that we have grown in an incubator in the lab for a couple of months, actually.
Oh my gosh.
It's really clearly very different,
it just
right?
looks
It's much
like
more
a child's
dense.
ear.
Absolutely.
When the ear is finally implanted underneath the skin, it will actually grow like a normal ear. Currently, the printed ears are in animal trials.
Oh my gosh, it has
And
like
it
a
has
real
the feel of tissue.
Bonassar modeled the ear after his daughter's ears with the hopes of treating children born without one or both ears, a rare condition called microtia. Right now, the best treatment for microtia is sculpting rib cage cartilage into an ear. Claire's mom, Kim Devane, has been considering the procedure for her daughter.
They obviously have to take out rib cartilage from her chest. It can be up to 6 surgeries, and it's painful. The doctor told Chelsea.
For now, Devane tries to hide Claire's missing ear, but she's hopeful for the promise of bioprinting.
If her hair is down, you wouldn't even notice her ears, really. So she's lucky. So I wouldn't put her through painful surgeries if I could wait, even if it was 5 years.
She may not have to wait that long.
We're going to make this structure right now.
Organovo, a company based in San Diego, is already printing human blood vessels and other tissues for drug research. Their printer, the first commercial bioprinter, is being used in labs across the country, like these at the Knight Cancer Institute at Oregon Health and Science University.
There's a camera right here, and we can see.
Professor Rosalie Sears is printing identical breast cancer tumors. Each tumor will be treated with a different drug.
This will allow us to actually, in real time, get a biopsy from a patient's tumor. Then we can load the printer with the different cell types and actually reprint the person's tissue, and then in real time, within a week, be able to test it and see what it responds to.
Sears thinks within a year, the printer could be used to help figure out which drug can best target an individual's cancer, leading to customized and successful cancer treatment.
I'm really excited about this because it could revolutionize how we do personalized medicine and treatment.
And she isn't the only one excited. Larry Bonassar of Cornell.
People are very interested in this for things like Alzheimer's and Parkinson's, as well as motor defects in the spinal cord. Printing is a potentially blockbuster development because patterning the cells in a way that makes sense that the body needs them patterned is really critical. And this is a fantastic tool to be able to do that.
From new treatments for cancer to someday new organs, your future may be a matter of some very fine print.